Properties of exponents in scientific notation. How can you perform operations of exponents in scientific notation? Well, let's talk about scientific notation for a second. We know that scientific notation is used when we want to show very large numbers and very small numbers. But we also have to be able to do our basic operations, in other words, to add, to subtract, to multiply, and to divide. So we need to take everything and kind of pull it together. So we're going to start out first by talking about addition. And what we want to do here is when we talk about addition is we want to first make sure they are the same power of 10. Now in this example, 3.1 times 10 to the 8th plus 3.38 times 10 to the 7th, we notice that they are both not the same power of 10. So we need to fix them so that they can be. Now let me just show you a little bit of information and then we'll decide which way we want to go. If I wanted to change 3.1 times 10 to the 8th to be a times 10 to the 7th, this would then become 31. We would move the decimal to the left one place in order to make it go down one place. Now if I wanted to make this become times 10 to the 8th, this then would become 0.338. In other words, in order for this to go up one, it would move to the left one. So we have to decide which way we want to go. So that's kind of our basic rule. If we want it to go down, we're going to go to the right. We want it to go up, we want to go to the left. So we can think of that as far as how we move things. Well, I'm going to decide to do 10 to the 7th. I'm going to take this one and that's how I'm going to change it. So I'm going to call this 31 times 10 to the 7th. And I'm going to add to it 3.38 times 10 to the 7th. So now they're the same base, same power of 10. And like I said, that's important. We've got the same power of 10 going on. So now we go to the next step, which is to add or subtract the multipliers. So we're going to take 31 and 3.38 and we're going to add those two numbers together and we're going to get 34.38 times 10 to the 7th. Now at this point we might want to stop, but we have to think about this a little bit. We have to remember that we need to leave things in correct scientific notation. Problem is we only need one number in front of the decimal and we have two. So we need to get that decimal to move over one spot. So we'll do that again and we'll rewrite it 3.438 times 10. And because we moved it to the left, we're going to have to increase this by 1 and it's going to become 3.438 times 10 to the 8th. Alright, we're going to continue on and do another problem here. This time we're going to try subtracting. We're going to take 1.1 times 10 to the 8th and we're going to subtract 3.38 times 10 to the 7th. Now once again, when we look and we notice that our powers of 10 are not the same. Since they're not the same, we need to fix it. So what we'll do is we'll change this first one and make it 11 times 10 to the 7th and we're going to subtract 3.38 times 10 to the 7th. So then we're going to take those multipliers. So I'm going to grab a calculator here. And what I'm going to do is I'm going to subtract 11 minus 3.38. And I get 7.62. So I know that that's going to become 7.62 times 10 to the 7th. And this is in correct scientific notation, so I don't need to worry about that. Now let's take a look at multiplying and dividing. So here we have 1.1 times 10 to the negative 2 and 3 times 10 to the 5th. We have to remember that we're looking at this a little bit differently. We're going to multiply or divide the first number. So let's take a look at what the first numbers are. 1.1 times 3. 1.1 times 3 is 3.3. Then what we're going to do is treat the base 10 with exponent rules. So we're going to take a look at 10 to the negative 2 and 10 to the 5th. Now remember, when our bases are the same, we're going to add these exponents. So a negative 2 and a positive 5 are positive 3. So this is going to become times 10 to the 3rd power. And since this is already in correct scientific notation, we don't have to worry about that going any further. We're going to do one more problem. Here we're going to look at a division problem. 4.2 times 10 to the 5th divided by 2.1 times 10 squared. We're going to treat them separately. We're going to take this 4.2 divided by 2.1 And when we do that, we're going to end up getting 2. And then we're going to take this 10 to the 5th divided by 10 squared and apply our exponent rules. They have the same base, so we're going to subtract those exponents. 5 minus 2 is 3. And there is, as it is simplified, 2 times 10 to the 3rd. Now, some people may not realize this isn't correct scientific notation. We have to remember that there is a decimal point behind the 2, so there's one number in front. So this will give you a little bit of everything on how scientific notation is done with operations.